Hello everyone. So in today's lecture we are going to discuss about memory addressing fundamentals. Okay. So here first of all we should know that the memory addressing starts from M. In case of Siemens, the memory addressing starts from M, and here if you observe, we have taken a CPU with a memory of 1000 bytes, right? So basically here MB0 means what? Memory byte 0. Similarly memory byte 1, similarly memory byte 2. In this way we are going up to MB 999, that means total 1000 bytes, right? So here if you observe, each and every byte, or we can say MB0, it has been divided into total how many bits? 8 bits. Actually I have already told you that the combination of 8 bits is called 1 byte, right? So here from 0 to 7 we are having, that means total how many bits? It is 8 bits, right? So M0.0 is 1 bit, similarly M0.1 is another bit, so we are going up to M0.7, right? So it is total 8 bits. Now if you observe carefully, M is known as identifier, right? And 0 is basically, here is the byte number and this is the bit number. After the decimal here it is called bit number, before the decimal it is byte number. Okay, so after completing 8 bits, see here 0 1 2 3 4 5 6 7, so after completing total 8 bits it will automatically get updated. This MB1 M0, here the value before the decimal will be updated. See here if you observe M1.0, M1.2, M1.3, in this way we are going up to M1.7. okay, so in this way we have total how many? 1000 byte of memory. So up to MB 999 we are going. Okay, so in this way, now observe here, we already know that here the combination of two bytes is basically one word, right? Similarly, so if you observe here MW0, MW0 means what? It is basically the memory word. Okay, so it is basically what we are representing, memory word. That means combination of MB0 and MB1, it is what? One memory word. Okay, so what is the address of that memory word? MW0. Okay, so this addressing is basically used for integer values, right? So if you want to take integer values, then we will be using this addressing. Similarly, if you observe here, MB2 and MB3, both the combination again forms what? 2 bytes, again one combination, which means MW2. Okay, so in this way there are so many number of memory words if you observe. Okay, so this is how we are doing the addressing of memory word. Okay, one important thing here to observe is we are not writing like this MW0 and then we are not writing MW1, we are directly writing MW2. This is why, because we need to actually one byte, or we can say one word will take 2 bytes. Okay, so what is the address of this byte? MB1. Okay, so it has been already taken by what? MW0. So if you are writing MW1, then this byte will also come under the influence of MW0 and also it will come under the influence of MW1. So there will be a chance of overlapping, which is not feasible in case of memory addressing. Okay, so that is why it is very important to note that in case of word addressing we need to address like this: MW0, then MW2, then MW4. Okay, similarly now we will move towards what? Memory double word. Okay, so actually we know that the combination of two words is called double word. Okay, so basically combination of 4 bytes is also known as double word. So here if you observe MB0, MB1, MB2 and MB3, both are this all these are forming a group of 4 bytes. So combination of 4 byte is basically memory double word 0, right? So memory double word 0 is basically combination of 4 bytes. Okay, basically 4 memory bytes. Okay, so here now when we will address the next memory double word, it will be md4. Okay, it will not be md1. Again the same case, if you are writing md1, then this mb1, okay, this will also come under the influence of md1. Okay, so again there will be a chance of overlapping. So in order to avoid overlapping, we need to address the memory double word in this way: md0, md4, md8, in this way. Okay, so here also you can observe here mw992, and then we are writing mw994. That means we are jumping from mw992 to mw994, because here also overlapping will be occurring. Okay, so it is very important to note that the addressing should be very proper in case of Siemens. Okay, now one important thing here is, in case of integer addressing, whenever we want to address the integers, okay, only integer values, that means the values which are not having decimal points. Okay, so in case of integer addressing we will be using mw0. Okay, basically we know that its maximum value will be 2 to the power 16, basically 16 bits. How many combinations? Minus 327682 plus 32767. Okay, similarly, if you want the values more than 32767, then we will be jumping to md0. Okay, so md0 is basically how much? 2 to the power 32 is maximum. If you take a case in which both positive and negative are considered, then we'll be having minus 2147483648 plus 2147483647. Okay, so in this way we are actually addressing the memory double word. Okay, so it is very important to note that while addressing the values which are more than 32767, then we'll be using md0. Okay, basically we'll be using memory double word. Okay, now important thing here to notice, if it is a floating point value. Okay, so if the value is floating point, then we can't use mw0. Basically it will not be accepted in case of floating point values. So we need to use md0. Basically double word can only accept the floating point values. Okay, so it is very important to note that the double word addressing will be used in case of floating point values. Okay, so in this way, this is what our memory addressing fundamentals. Okay, so it is very important. Okay, so thank you. Remaining things will be taking in the next class.